Hey guys, and welcome to another episode of the Inventory Remake 2024 series. In this episode, we will get through the saving and loading of the inventory system, and if there's extra time, we'll also work on the. Right now, if you have a bunch of items and you die, then you lose all your items. So we're going to set up a system for maintaining items on death as well. It also seems like there's some other bugs, so we're probably doing some bug fixing with that as well. So the first thing we want to do is we're going to go to server script service, server, and then inventory server. And we believe we might have already made a function. Yeah, save data and load data. Now we're going to actually define these functions, because right now we just have little warnings in here saying that they haven't been set up yet. And I believe we also already called these functions. So we already have, this part's going to run anytime the server shuts down, and it's going to loop through all the players and run the save data function for every player. And this one is just a loop that'll save every player's data with a specific autosave time, and it'll save it every, in this case, 3 minutes, right? And then for the load data, I believe we're calling that in the onPlayerAdded right here. So we already have all the calls set up, so now we just need to set up the functions themselves, and it should work appropriately. They should run when we need to run. So the first thing we're going to do, so the idea of what we want to do when we're saving the data, so we have the data itself is going to be inside all inventories, and it's going to be the inventory object right here, types.inventory. This is going to be the data that we want to save, but how we want to save it is, we could pretty much just convert that table into a string and then store it in a data store. That's pretty much all we need to do. Is down here we're going to do creating save string. Local inventory is going to be, that what the AI said. So basically what we're going to do, we're going to get the inventory, and then we're going to need HTTP service. So I'm going to define that up here. So define HTTP service like this. Then we're going to go way back down here, and then we're going to take this. So this is a table, right? It's the inventory table, and we're going to even specify types.inventory. And then we're going to do local data string is equal to HS JSON encode. So I have to capitalize it properly. JSON encode inventory. So HTTP service is used for like HTTP request and like API and different things like that. But all we're using it for here is just for its ability to convert a table into a JSON string, which a JSON string is just, it's basically a way of like, so if I do like example table, so if I make the command, I'll just make a new script, that'll be easier. So I do like local example is equal to the table, and we have like inventory armor equals, I don't know, head equals iron helmet. This isn't how you would actually define the armor, but you know. So then if we had HTTP service, then we can take this table, so we can just print the table as is, right? And if we run the game, it'll print the table, and we can look at it because of the output's all fancy, it lets you look at tables. But if the output wasn't all fancy, or if we wanted for some reason to store this as a string, maybe, you know, it's more, it doesn't take as much memory that way because you don't have all the different like data for the specific object type of a table. But you could turn this into a string by doing HS JSON encode example, and now when we print it, we'll see the string, and this is what a JSON string looks like. And you can kind of like, you can format it to where it looks a little nicer, it's a little easier to tell what's what, but it's basically just, it's from JavaScript. JSON stands for JavaScript object notation, but it's a specific notation that's used pretty widely for storing objects, basically. But then there's also, then we could do, you could print JSON again, then we could do local example 2 JSON decode, and then we decode the JSON again, and we can print the example 2. Maybe do print example equal to example 2. We run it again, and we can see that. So we have the JSON string that's created from the table, and then we take that JSON string and we turn it back into a table again. But the difference here is that this new table is not the same table as this one. So this table is stored somewhere in the memory. It has some sort of memory address. And if we did local example 3 equals example, then if we printed example 3 equals example like we're doing here, it would check if example 3 is the same object as example, and it would return true because this is just setting a reference to where this is stored in the memory. But in this case, this is creating an entirely new table using the JSON string, and so these are not equal because they're not stored in the same part of the memory. That's not really relevant to this. I got a little distracted there. But the point is we're going to be using JSON encode and JSON decode. So we take this data string, so we convert the inventory table into a JSON string. Let's just run this and just see what happens. So we do like print data string. So it should do an autosave, but I'm just going to leave and it'll trigger the save because the server is shutting down. And we see it prints the JSON string right here. So it looks like it works fine. And one thing I'm worried about is the items table, or the items tables for each stack, because those have tools in them. But it might just automatically kind of just turn those into empty tables. Yeah, it just sets those to null, sort of. I think we will need to modify this. Yeah, we will need to modify this. So what we're going to do is we're going to take, before we turn this into a data string, we're going to do local modified inv is going to be equal to a new table, and we're going to set the inventory is equal to a table. I'm going to set hotbar equals table, armor equals a table, next stack ID. So it's pretty much going to be the same. The only thing we're going to modify is the actual stack datas, I believe. So next stack ID is going to be equal to im.next stack ID. And then the armor and the hotbar, we can just copy those directly over. If we just do im.hotbar, that'll reference im's hotbar table to im.armor. So now these are just going to be directly copied over to our modified inventory. But for the actual inventory table itself, where all the stack data is stored, what we're going to do is we're going to remove this part, this property, the items, the list of items in the stack, and we're going to replace it with a count, which is just going to be the number of items in the stack, because we already have the item name. So all we need for the saving is just going to be the item name and the amount of items. But from the item name, we're going to have a list of sample items in server storage that we're going to be able to reference. So what we're going to do is we're going to take this modified inventory. So we're going to loop through all the stacks. Stack data. I need to specify that in im.inventory do. Then we're going to do modified inventory or local. Just table to insert modified inventory. Insert a new empty table. But then in this table, we're going to specify that we want the name equals stack data.name, and then the count equals number of stack data.items. And that's all we're going to need to store. So we don't want to store any more than we need to, because that's just wasted memory space, wasted storage space. All these other things, okay, this is a typo. Is that typo? Right, and that's the only place that typo is at. Interesting. Alright, but anyway, so we're not going to need all these other things, because those are just going to be taken from the tool objects itself. Those are going to be stored on the sample item itself. So all we need is just the name and the number of items that we want to copy over when we load, right? And we also might need a stack ID, yeah, because that's going to be important for saving the hotbar and the armor, because that's what the hotbar and armor reference. So stack ID is equal to stack ID. And I believe that's everything. The image is also going to come from the tool, description is going to come from the tool, item type is going to come from the tool. And if you have any other attributes on the tool that you added yourself, you're also going to want to, you also don't need to save those if you have those on the tool itself. All right, so we're looping through, so we're going to add this modified stack data for every stack. And then after we've done that, we pretty much have our modified inventory. So then we're going to do local save string equals HTTP service JSON encode, and we're going to do modified inventory. So then for now I'm just going to print the save string. We can see what it looks like. Run the game, and if we leave, then this is what our inventory saved edit is going to look like. So we have the, oh wait, no, this needs to be modified inventory.inventory. So that was a mistake I made. So now if we leave, okay, there we go. So the modified inventory has the inventory, which maps to a list of the stack datas, but modified, so it only includes these three values. And then it has the hotbar and it has the armor as well. And as you can see, the hotbar maps the slot keys to the stack IDs. So we want to make sure we preserve the stack IDs, which is why I added this here. To actually save this, all we need to do is we need to define so we need to get data store service. That's local DSS equals game service, data store service. And then we're going to do data stores, local IDS equal to data store service, get data store, inventory data store. This is just a naming convention I have. It's just an acronym for inventory data store. You can name whatever you want as long as you are consistent with this name. If you use this data store in other scripts or anything, then you can name it whatever you want. Local save key equals, and this is going to be like a format string, which I'll kind of explain that. So what's going on here is so when you save data, you need to specify a key to save it to. So that's just going to be any sort of string. And generally what people use is going to be the player's user ID, because that's going to be unique to that player. But what I like to do is I like to attach a little string on top of the user ID. So this percentage I is going to be replaced with the user ID using string.format. And then it's going to add this to the string as well, which is just like version 0.1, right? And the idea with this is if you wanted to like reset the data, but also be able to revert if you wanted to, then all you have to do is just change this from 1 to 2, and now you have and then now everybody's data is going to be a different key for every player, because it's a ever so slightly different string. And so when they load in the game, it's going to detect that they don't have any data, and it's going to reset their data basically, right? And it's going to do it with this new key. But then if you switch this back, it's going to revert back to their old data. So this is useful if you ever need to do like a data reset, maybe just for testing purposes or something like that, right? Maybe you're like trying to make something for the inventory system or for something else, and you save the data, but then what data saves ends up breaking your system, and so you need to reset the data to be able to actually like fix it and test it and do stuff like that. So this can be useful. Anyway, so we create our data store with this, and then we get a save key like that. And so then with those two things, we're going to go back down here, and then what we're going to do is we're going to do IDS set async, and this is where we want it. So this is basically the save function for data stores. And then what we need to do is we need to specify the key, and we need to specify the value. So what we're going to do is we're going to do save key, and we're going to do :format. And by the way, that's the same as doing string.format save key, and then adding your other things after this. But you can also do it like this. So save key :format. And if you remember, we have this %I. Anything that's followed by a percentage is going to be a value that you can replace with the format function. So we have one value to replace, so we need to provide one argument into the format function. So we're going to provide player.userid. Let me specify that this is a player object. This is a player object. Make sure just because that helps with like preventing typos and things like that. Make sure you're typing it right. So this is going to be our save key, and it's just formatted for that player's user ID. And then you want to add the value. In this case, our value is just going to be the save string, and that's pretty much going to be the save function right there. We can also add some prints. So I might do like print inventory saving the data of player.name dash. Just kind of like give a little message in the output. And down here we can also do so. Now if we run it, it won't actually load the data. So this is just going to be saving the data. It's not going to actually load it or anything. But it does seem like, okay, I don't have API services enabled. So you need to make sure, in order to test data store in Roblox Studio, you need to go over to Game Settings, Security, and then enable Studio access to API services. And hit save. And that should get rid of that error message. If we leave, you can see it says saving the data of 1919 and our user ID, finish saving the data. So it saved the data in theory, but we need to actually load the data now. So in order to actually load the data, this is going to be the more complicated part of this episode. So we're going to do same sort of print as earlier, print. So then inside this, we're going to get the data. So getting current data. So this is how you save data to a specific key. In order to get data from a specific key, you can do local save string equals IDS get async, and then do your same key, format player.userid, and then it only has the one argument. So you specify the key with get async, and it's going to return what value is currently stored at that key. So then what you can do, so this is now going to be, in theory, it's going to be our save string, or it's going to be nil in the case that there's no data, or in the case of like something broke or anything like that. And oftentimes you do want to do a pcall function, so I might do like local success result equals pcall function, because sometimes these data store calls can error. So if I do like local success equals false, result false comma nil, then yeah, so we're going to set local success result equals false nil. This is just shorthand for setting two different variables in the same line. And then we're going to say success result equals pcall function. So a pcall is a way of running a function where if there's an error, it won't stop the code. It'll simply set success to false and result to the error message, so that we can just print the error message and keep the code running. Or if there's not an error, it'll set success to true and result to whatever this function returns. So in our case, we're going to run the set async function, and there might be an error because sometimes data store has errors, right? And what we can do, this is kind of like a hacky fix. There's probably better ways to do this, but just for the sake of this tutorial, if you want to use more secure data store, I've heard some really good open source modules you can use are like Profile Service or Data Store 2, and the process would be roughly the same for how you save data and load data, I imagine, but it probably has more security things and like making sure you don't lose data or anything. But in this video, I'm just going to do this really basic thing. I'm just going to do while not success do. We're pretty much just run this on repeat, but we do want to make sure this doesn't like run forever. I'm going to add a task.wait just in case. Task.wait. And then we're going to do local timeout time equals maybe like 5 seconds, and then local start time with os.clock. Attempting save. And then we're going to do, put that down there. Time out checking if os.clock minus start time is greater than timeout time, then print inventory thing unable to save the data of player.name. I'm going to do break, or I guess just return, because we don't want to print this message. So here you might want to like do something that actually handles this case of like what happens when it fails to save. But I'm just going to leave this as is. So basically what we're going to do here, what's going on here, so we have the success and result. We're just setting those as variables outside here, so that way we can update those variables every time this runs. Then we have a timeout time. This is 5 seconds. So this is going to repeatedly attempt to save, and if it ever succeeds, then it's just going to move on and it's going to print that it finished saving the data. But if because it says while not success, right? So if success is true, then this is just going to stop running, right? If success is false, it's going to run it again and try to do it again. So then what this part is doing is saying, so this timeout time, so this could run theoretically if there was something wrong that just made so the data saving was just not working whatsoever, just spamming error messages over and over, then we wouldn't want to have this just run on forever and ever and ever, right? So we want it to time out after a while. I might do down here, if not success, then task.wait 1 second, because running every frame is going to be a little bit chaotic, I think. So now there's going to be a cooldown. If it fails, it'll wait a second before it tries again. And then after 5 seconds, it'll check this. So the start time is set to os.clock. This is a function that returns like the amount of time since a specific fixed point in time way back when. And so you can use os.clock. I think it has to do with like the CPU runtime or something as well. I don't know. Well, basically, we can use that to determine how much time has passed since we started this loop. So os.clock minus start time is going to be the amount of time that has passed since we set this variable. So we can check if that's greater than 5 seconds. And if it is, then we print that we are unable to save the data and we return, basically. You could also have like a counter that counts the amount of attempts and have a max number of attempts, and that would work too. But this is how I'm going to do here. So after 5 seconds of not succeeding, it's going to, and probably around 4 attempts, then it's going to print that it failed to save. And so this will handle any errors roughly. I mean, it's not going to really do anything for those errors, but that's going to be our save data. And we probably won't really see it doing anything. It'll just, finish saving the data because it just succeeds. But then back to our loading data. This is where it's going to get a little bit more complicated. So we have our save string. It's going to say get async. It's going to get the data, so we can then print that data just to see what it looks like. And this should be just our JSON string that we saved. So when we print it, we can see it has that JSON string. So it loads that JSON string and it has that available. So then we need to actually load the items from that. And in order to load the items, what we're going to need to do is we're going to need to have a reference for every item in the game. So what I like to do, so if I'm going to the server storage, add a new folder, call it all items. And then any item you have in the game, you want to have a reference to it. You want to have a copy of it in here. In our starter pack, I'm going to take all these items. I'm just going to remove them from the starter pack, paste them into here. So, because this is all the items that I have. And so you want to make sure these all have the proper attributes and the properties and different things. And they also have all the stuff inside of them that you need inside of them. These are going to be our references for these items. And you also want to make sure each item has a unique name, because I'm going to be saving and loading them based on the names of the items. So that's going to be important as well. And just so we can pick items up if we want to, I'm going to put a copy of these in the workspace. That way we can touch them and pick them up with the default pickup system. Okay, so now for the loading, so we have our save string that we printed earlier. So now we want to turn that save string back into a table. But save string could be nil. If there's no data, it's going to be nil. So we want to say if not save string, then I guess better yet, if save string equals nil, then we're going to say print inventory no data found for player, player.user, player.name, user ID, and then we're going to return and just end it right there. Then we're going to say if there is a save string, we're going to do local saved data equals JSON or HTTP service JSON decode save string, and if we print that saved data, you're going to see it prints the table. So this is not we don't want to just set the inventory as this, because it's going to be a little bit different than our actual inventory. So it has all of our stacks, but the stacks don't have the same data. It's kind of simplified a little bit, but this is going to have enough information for us to load the items. And also when I leave here, since I don't have any items, since we never actually loaded them, it's going to save an empty inventory. So when I run again, that table is going to show an empty inventory now. So that's why I added these in here for the testing purposes. So now if I pick these up again, if I just touch them all, then I have all of them, I can leave and it'll save that I have those again. I'm also going to remove this random print. Okay, so back in inventory server, we want to look at the load data function. So we have our saved data. So now with this saved data, we want to create a new inventory. So loading inventory, local new, or local, I'll just call it in, equals types.inventory equals an empty table, inventory equals an empty table, hotbar. So I'm pretty sure we can just set the hotbar directly to save data.hotbar, and then armor equals save data.armor, and then the next stack ID is going to be save data.next stack ID. And this is important to keep track of because that's going to determine, well, the next stack's ID, right? So if we have, right here we have an empty inventory. If we load it again, we should have our non-empty inventory. Oh, we don't have the printing. So if I add the print again, print saved. Now it's going to be empty again because I pick up all my items, leave the game, saves the data, play the game. We have our inventory items and we have our hotbar. We want to make sure we save the next stack ID because our last stack has a stack ID of 4. So if we don't save the next stack ID, that's going to and we default it to 0 again, then we're going to have 2 stacks of stack ID 0 because we already have a stack ID of stack. We already have a stack of stack ID 0. So we want to make sure we save that as well. So then this is going to be our new inventory, and we need to go and individually load each stack. What we're going to do is we're going to say local backpack equals player, local character is equal to, it's going to be a model, is equal to player dot character or player dot character added weight. So we're going to find the character, and we don't really need the character. I'm mostly just doing this because we want to wait for the character to be loaded in. Because because we want to get the backpack, that's what we need. Child backpack. But there's a weird bug where or not really a bug, which is kind of a weird finicky thing, where anytime your player dies and respawns, it'll destroy the backpack and create a new one, which is why the items reset. But it also, when you first join the game, you have a backpack in your player before you spawn in. But then when you spawn in for the first time, it does that same thing where it destroys the backpack and recreates it. So if we load everything if we just did this, and we didn't wait for the character, then this might get the backpack that exists before the character loads in, and it would load all the items into that backpack, and then that backpack would be destroyed, and then it wouldn't have actually done anything, right? We'd lose all the items. So we want to make sure we wait for the character first, then find the backpack, and we're going to do for I comma saved stack in pairs, or in save data inventory do. This is saved data. We're going to loop through every stack in the saved data, and for each one, we're going to find the sample item. Find the sample item. So I'm going to define some variables up here. We're going to define server storage, game service, server storage. Define server storage, and then do local sample, which is going to be a tool, is equal to server storage.all items. Find first child saved stack.name. So this is going to reference the item in here based on the name of the stack. And so we do want to add a little error message. If not sample, then warn no item sample was found in server storage.all items for the saved stack.name, and then return, or break rather, or continue rather. So basically, we're going to look and we're going to see if there's a tool in all items that matches this stack's name, and if there isn't, we're going to print a little warn message, just kind of as a reminder, because you probably forgot to add it in here. And then we're going to continue, which is just going to skip the rest of this iteration of this for loop, and it's just going to go to the next iteration. So it's sort of like return, but only for one iteration of the for loop. We're going to create a new stack. Stack types.stack data equals. We're going to specify the name as saved stack.name. Items equals an empty table. Stack ID equals saved stack.stack ID. let's see, what other properties are there? So there's name, description. So we want to get the description. Description equals, and we're going to do, we have the sample, so we're going to do sample get attribute, or no, sample dot tooltip. That's where we get the description from. And then the image is going to be the texture. So image equals sample dot texture ID. And then after that is the item type. So item type is going to be sample. This one's going to be an attribute. Get attribute item type. So you want to make sure item type is specified for all your tools and stuff right here. And same for is droppable. So then is droppable equals sample get attribute is droppable. And then we have our items and then our stack ID. And our items, we're going to set that to an empty table for now because we're going to have to load all those items in. And then what we're going to do is we're going to load those items in. So then loading items, we're going to say for I comma or I equals 1 comma or saved stack dot count, because remember we saved the count right here. That's going to be the number of items. For I equals 1 comma that do, and we're going to do local clone equals sample clone. Clone.parent equals backpack. Table.insert stack.items clone. So we insert that into the table. And so then after this, we should have our whole stack loaded in. So then we just should insert that stack into the inventory. Table.insert new, or table.insert m.inventory. And we're going to do our new stack. And that should load each stack like that. So then, after we've loaded each stack, I believe all we really need to do is just say inventory server.allinventories player equals inventory. So we're gonna, whenever you first run the game, right, it's gonna create a new inventory. This is gonna be like the default empty inventory. So it's gonna create a new inventory and then it's gonna try loading. It's gonna run this load function right here. I guess we didn't actually need to wait for the character because it looks like we already did that here. But it's going to run the load data function, and then remove this print, and then it's going to create the new inventory. It's going to define all the stacks and do all that stuff, load all the tools and stuff, and then it's going to replace the default inventory with the new inventory, basically, right? And so this, in theory, should work. But there is going to be some errors we're going to have to fix. So I don't know if it had the items. Let me see. So I'm going to add those prints back in. So I'm going to add on save, I'm going to add, let's see, print modified inventory on save, and on load, I'm going to do print saved data. So this is the data we had saved, no items or anything. So we're going to pick up a bunch of items. We're going to leave the game, it's going to save, and it'll save those new items that we picked up. See all the new items and stuff. We run the game, it should load those new items, and we can see it did add them back into our inventory. And it looks like it even loaded the hotbar and stuff as well, so it looks like that did work correctly. And it looks like it all works fine. So that's pretty much saving and loading done. And it should work for armor as well once we get that set up, because armor is going to be in the actual data itself. It's going to be stored in the exact same way as the hotbar. And we're already loading it the same way, so that should work as well. But then there is one little thing that can be an issue. So I'm going to remove these prints. So one thing that can be an issue is if you were to join the game and then leave it really fast. So in this case, I didn't leave it fast enough. But basically, if you leave the game before it finishes loading, then it'll prompt it to save the data before it actually loaded. And it'll save empty data. So then when you rejoin, you'll have empty data because that's what it saved. And so then that's going to mess everything up, right? You're going to lose all your data. So in order to prevent that, we're going to do a little thing. We're going to say, we're going to new thing up here. We're going to call it inventory server dot has loaded. So then with this, so this is going to be a table that we store for all the players. And by default, it's just not going to have anything in it. So then if we do up here in the save function, we're going to say if not inventory dot or inventory.hasLoaded player, then return end. So if there isn't a value that's, or I guess if, to be more specific, if it's not equal to true, then return end. So if, when we first run the game, this has loaded is just going to be an empty table. And so if we try to index it with player, it's just going to give us nil. And so nil is not equal to true, so we return. So basically the data hasn't loaded, and so we return. But then if we go down here to load data, we're going to set inventory server.hasLoaded player equals true. So now it's going to set that value to true. So once the data is actually loaded, it's going to, and then we try saving, so we leave after it's loaded, then it'll say inventory server.hasLoaded player. Well, that's set to true. And so we don't run this, and we keep going, and we save the data. But then one thing we want to keep track of is that this value is going to be stored for this player, but then when the player leaves, that value is going to stay there. And so if you have players joining, leaving, joining, leaving, joining, leaving, it's going to have a whole bunch of values in there for no reason. It's going to waste a bunch of memory. It's probably going to slow down the server a little bit. So we want to make sure we remove that when the player leaves. And luckily, I believe, we already have a system set up for that. This janitor thing. Whenever a new player joins, it creates a new janitor object for that specific player. And then whenever the player leaves, it does all the chores of that janitor. And so all we have to do is just go down here, and we can set inventory server.janitors player give chore. We're going to do a function inventory server.hasLoaded player equals nil. So that's going to remove that value from the table whenever the player leaves the game. So that'll work good. And that should fix that little bug I was talking about. Except I wasn't actually able to. Okay, it looks like it might have broke. Maybe I did leave and join fast enough because my inventory is empty now. Unless, now I have 2 items. So I wonder if it did load, but it didn't update the UI. So maybe one thing we're going to do is after we load the data, go down here, update client UI. So we're going to do signal fire client player, and then what else do we need to specify for that? All this stuff. So we want to update the UI. So now we should have 2 copies of everything. Yeah. So I think it wasn't updating the UI because I think maybe it was loading the data before the client ran the initial update display function call. So you want to make sure you update the data after, or you update the UI after it loads the data. And that, I believe, now loading and saving should work fine. I can leave, I can rejoin, have the same items, and it all seems like it works good. And I believe it'll even save, if I unequip all these items from the hotbar, maybe I equip that one to slot 0 or something, it should save where the hotbar items are as well. Yep. Looks like it all works. So then the last thing I'm going to do in this episode is I'm going to set up making so you don't lose items when you die. The first thing we're going to set up, I don't know why I closed that script because I do still need it. First we're going to set up is another table similar to the janitors and the has loaded. We're going to set up a table called inventory server.respawning. And this is also going to have players as indices and booleans as values. And so what this is going to keep track of is whether or not the player is currently respawning. So I'm going to set that up by going into player added. So in here I'm going to do inventory server.respawning player equals nil. Just because we want to make sure that it clears the value whenever the player leaves, because that's in the janitor give chore, right? So this is going to run whenever the player leaves. So I want to make sure we clear any values, same as before, right? And then after that, or what we also want to do, we want to set respawning for that player to true whenever they die, and then to false whenever they respawn, whenever their character loads back in again. So we want to go to we want to run connect on humanoid.die in order to track when the character dies, and then set respawning to true, and then wait for them to respawn, and then set respawning to false or to nil, just to clear them, just to not waste memory. So we're going to go into the character added function inside player added, and then down here on character def, we're going to do local humanoid is equal to character wait for child humanoid. So then when humanoid.died, we're going to connect to that event, and we're going to say, so one thing we need to do, this is actually going to be a little bug fix, is we want to, so unequipping or unholding items and starting respawn. So we want to say, we want to run inventory server to unhold items for that player, and the reason for that is because when you die, if you have an item in your hand and you die, then that item is going to fall into the void because it's inside your character, and so you're probably going to lose that item. So we want to, right when you die, we want to unhold all the items, so that way the item goes back into your backpack before it has time to fall into the void, and then you don't lose that item. Then we're going to do inventory server dot respawning player equals true. So now we're saying the player has started respawning. I might actually flip the order of those. The player started respawning, and then what we're going to do while the player is respawning, character respawning, we're going to do player.character added wait local backpack. We're going to reference the new backpack. Local backpack is a little player wait for child backpack, because now that you've respawned, we want to wait for the new backpack, right? Because it's going to destroy it and add a new one. So then this is going to be after the character respawned again. So then we want to do inventory server dot respawning player equals false. This isn't going to fix the whole, this isn't going to like keep items on death yet. There's still some more stuff we need to do here, but this is going to keep track of whether or not we're currently respawning. And with that, we want to disable some functions while we're currently respawning. We're going to disable a lot of functions actually. So on register item at the very top, if inventory server dot respawning player, then return end. So we don't want to register any items that are added into the player's backpack or character while they're currently respawning, because we're going to do some fancy stuff where whenever the player dies, we're going to temporarily move all their tools to a different location, and then when they respawn, we're going to move it back into their new backpack. It's kind of a little hacky fix, but it works. And so while that's happening, we don't want it to be registering those items, because we want it to just keep the same references to those items that it already has. There's no reason for it to unregister them all and then re-register them all. That's just going to like mess up the hotbar and everything, right? And probably cause other bugs. So we're going to return on register item if they're respawning. And we're going to do the same thing in unregister item. Just copy that line, paste it down here. We're going to do that in hold item, because we don't want players to be able to hold items while they're respawning, because then that's going to kind of ruin the whole point of what we did in the player added, where we unhold the items when they die. If we unhold the items and then they can still just hold the item again, it's just going to drop the item into the void again after we've already run this function. So we want to disable holding items while they're respawning as well. And then we're going to do the same thing for unholding items. So let me minimize everything because I've lost what I'm doing. Okay. Unhold items, we're going to do the same thing here. We're going to do the same thing for equipping and unequipping to the hotbar. Add those to those two functions. We're also going to do for armor and some other things, but we'll do that when we actually set those up, because I know those are not set up. But I believe that is everywhere that we want to do that. So now that should disable all those functions on respawning. So now we're going to go back to our player added, and we're going to finish this up a little bit. So then we're going to say, after we set respawn to true and we unhold all the items, we're going to wait for the character, or before we wait for the character to respawn, we want to take all the items and reparent them somewhere else that's not going to like get destroyed, like the backpack, because right now the backpack is about to be destroyed because the character just died, So local, or reparenting all items, local items is going to be just a list of tools, right? We go to player.backpack, get children, and then we're going to loop through all the items in all items, and we're going to do item.parent, and I'm just going to set the parent to this script, right? To this module script. It doesn't really matter where you set it to as long as the location isn't going to be destroyed, and ideally maybe somewhere where the client doesn't have access to it, just in case it like helps prevent any like weird exploit issues or anything. So the script is in server script service, which is only visible by the server. So that works good. And we're already keeping track of all the tools. So if two players die at the same time and it puts all their tools inside the script, it doesn't really matter because we're already keeping track of every single tool. With this all items table, we have a reference to every one of the tools. And all we need to do is just loop through this. Whenever we add those tools back, we just need to loop through this table again and reparent those tools, right? So we don't need to worry about where it goes or keeping track of them in like folders or anything. We can just put them all and just throw them all in the script randomly, and we'll be able to reparent them correctly. So after the character respawns, before we do the respawning equals false, then we're going to do adding items back. So we're going to do what I just said. So for I item tool and all items, do item.parent is equal to the new backpack. That's going to re-add those items back into the backpack after they respawned. And then we set respawning to false. So now it's going to, since respawning is set to true, while it's doing all these moving things, it's not going to register unregistered items or do anything like that. So it's just going to skip over all those functions. It's going to ignore those until we set this back to false, or rather I'm going to set this to nil. And then it should maintain the items. So if we run the game, we have all our items. In our inventory, we have the hotbar set up and everything. We can hold items, all that good stuff. If we reset, let's see what happens. It looks like the whole inventory system broke because it's not even updated or anything. So that might be, I guess, an inventory client issue. If we look at the backpack, we do still have the items. So it's just a display issue. So the whole inventory client broke, and I think the reason for that, I might have forgotten a small thing. Yeah, so one thing you want to make sure with your GUI, make sure that inventory, the GUI, has reset on spawn set to false. Because basically, with how we have the script set up, so basically, if reset on spawn is set to true, then whenever you die, this GUI is going to get destroyed and remade, right? Which is why everything in the display broke when we respawned, right? Because it removed the UI and added a new one, and we don't have references to those new UIs because our script is running in the player, which does not reset when the player dies and respawns. If we had this running inside our character, it would reset, but we don't. We have it running in the player scripts, so we want to make sure it doesn't reset, because otherwise it breaks our code. So once we turn that to false, that should work fine. So we have our items. Because it did like still save the items, so we didn't lose the items. It was just a visual display issue. Now if we reset, it maintains the hotbar, it maintains all the items, it maintains everything, and we can still hold them, we can still do all these different things. I believe we can still unequip, equip, and it looks like everything retains over death, so that works great. So now items save when we leave and rejoin, and they save when we die and respawn as well. And so that's probably going to be the end of this episode. We got through a fair bit in this episode, and hopefully this is pretty much a fairly good ending point for people who don't need the custom dropping system or who don't need an armor system or anything like that. This is a pretty good stopping point. However, I will be continuing this series. I will be doing a custom dropping system with proximity prompts and like actually making, because right now we have this max stacks right here, but it doesn't actually do anything. If you go over that, it just kind of doesn't display those items. So we're going to actually do some stuff with that. We're going to set up the armor system as well, which is going to be a really big part. It'll probably take a couple episodes. But so stick around for that if you're interested in that. And that will be the end of this episode. If you need any help with anything, you can always join my Discord server in the description and ask questions in the development questions channel. And if you're interested in getting files for my tutorial videos, you can access all those files with either the YouTube or Patreon membership for $2.99 a month. And additionally, if you're interested in one-on-one tutoring with me, just virtual over like Discord or something, then you can purchase the higher level memberships for varying levels of hours each month of tutoring one-on-one with me. And I can help you with your projects, I can help you learn whatever you want to learn, and it can kind of be guided by what you want to get out of it. Anyway, I'll see you, and thank you for watching.